in repeating, I'm not going to discuss supply chain risk management itself is a course. So I'm not going to the details of it, but what I'm going to discuss how to model a supply chain risk, right? So think about a simple scenario, not a simple scenario. It has become a very big case. This epidemic happened, pandemic happened, right? Last 2 years back. It is one of the kind of a century, maybe in 100 years, this kind of events happen, right? So this is something known as a ripple effect, right? Something started as a ripple, like you throw a stone into a pond, right? And lot of disruptions, like back in 2019, I remember December or January, there was certain news in Wuhan, and nobody cared about that, right? And within 2 years, like lot of changes has happened across world, right? Lot of disruptions happened, and mostly it has impacted the manufacturing or the supply chain, right? So this is something known as a ripple effect, right? Once in a lifetime event, sometime it will happen, not regularly, but it has a huge impact, right? Obviously, like anticipating that is a when it will happen, it is a big risk. I'll not say big risk, big challenge, right? Nobody can anticipate when the next pandemic will happen, right? But you know that these kind of events will keep happening. Even not a pandemic, sometimes earthquake will happen. Uh, Russia and Ukraine war right now has happened. Oil prices has keep increasing, right? So lot of challenges are happening across global like scenario, right? And it keeps happening. It is not that right now in the last 2 or 3 years these things are happening. If you look back into last decade, some things happen like that. Lot of wars happened. Again, back from 2000 to 2010, lot of wars, petrol prices rose like anything. 2018 financial crisis, right? So the point is, you cannot anticipate when the risk will happen, right? So that is kind of impossible, right? Lot of kind of connections are there, lot of things which you cannot predict, right? This is something known as unknown unknowns, right? But what we can do, what is the impact of that, right? If we can anticipate if some impact will happen, let's say think about this iPhone, Apple, right? So they have manufacturing plants across world. They also have warehouses. They also will have dealers, distributors across world, right? If I can anticipate any event happens, right? I'm not kind of concerned about which kind of event, but if I can anticipate the impact of that event, if certain event of this kind of ripple event or ripple effect or a bullwhip effect, everybody knows, right? Regularly keeps happening, right? So that is a normally in the forecasting we take into consideration. But we are talking about, mostly we'll be talking about the ripple effect here, right? So the point is, if these kind of events happen, war happens, earthquake happens, flooding happens, or this pandemic happens, right? If I can anticipate the impact, I know that my plants are across India, China, and let's say there is a probable war between tension between India, China. Some transportation or supply chain will be disrupted between India, China. So let's say Indian government says tomorrow they will not allow any products from China, right? How it is going to impact my supply chain? So it might never happen. But if it happens, can Apple anticipate that impact and model a supply chain that, okay, if this disruption happens, how can I make my supply chain resilient to like mitigate or to at least withstand this kind of disruption, right? For let's say 3 months, 6 months, or 1 year, Indian government do not allow any products from China, any Apple product or any kind of manufacturing product from China. So in that case, what will do? So there are customers in India, right? If I want to serve them with my products because that is a big market, then what kind of alternatives we have? If I can plan that ahead, it is not that I'm doing all the investment, but if I can plan that, okay, if this happens, then this will be the my action plan, right? And so this is something which is known as modeling risks in your supply chain, right? If you can like, and there can be a lot of risk, right? I have certain suppliers from Mexico. Let's say due to certain problem, the main supplier of not Mexico, maybe like let's say Taiwan or somewhere, the electronic chip manufacturer, that plant gets shut down. The supplier gets bankrupt. Then what kind of alternative we have? So that is also one kind of risk, right? Sometimes in a ripple effect, sometimes it will happen. Some problem happened in Taiwan economy right now, which is happening in Sri Lankan economy, right? then what will be the impact of that on my supply chain, right? If I can anticipate, build a model for that, and according to that, I will have certain backup plan, right? So this is what we are going to discuss that and how to carry out, which kind of parameters we have to look into that, right? So Bullwhip effect, I guess all of you know. So this happens generally due to our kind of always we take little backup, right? So if a retailer forecast customer demand is 10 units, retailer will order 15 units, and then when a distributor is ordering, he'll order 20 units. By the time it reaches manufacturing unit, the plant manager will think that okay, they have to manufacture 40 units, right? So like a bullwhip, it keeps upgrade, like increasing the depth or the height of the whip. It keeps increasing, right? This is a like well-studied phenomena, right? So this is where a lot of triangulation of forecast happens. So earlier, what used to happen, information technology was not there. So through a phone or through some kind of email, those kind of details were being said. Now, when you have a ERP system, so somebody's orders 15 and last 15 months or 20 months on an average, they are only selling 10 units. Obviously we are going to ask them the question, because in the database you can within a few clicks, not within a few clicks, without any click also dashboard is given that retailer who is suddenly ordering 15 units, but you have seen that on average he is only selling 10 units or 8 units. Let's say we are talking about the certain car manufacturer, certain retailer or certain this showroom suddenly orders 15 models, right? Now you might ask them the question, Array, last 24 months or 3 years you have been only selling 6 or 8 units, suddenly why you are putting a double order, right? If that clarification is there, then will only you send that order to your manufacturer, right? So that kind of check only is possible now because we have an integrated supply chain where your information system is integrated across your retailer, distributor, manufacturer, and from manufacturer to supplier. If suddenly manufacturer Maruti orders uh, 20,000 tires or 50,000 tires from MRF, which is more than 10,000 units, which they regularly order, MRF is going to come back and ask, right? Which was not possible 20, 30 years back when this information was not integrated, right? But what we are going to discuss today is about the ripple effect, right? So this is the operational risk, recurrent. It keeps happening, and we right now, at least most of the organizations, right, have a at least kind of range, minimum, maximum. If also the order falls below a minimum range, automatic question is going to the retailer. If order falls above maximum range, automated question is going to the, are you sure to order this much units, right? So this can be easily, I'll not say easily, but there is a method or there are processes, there are systems to tackle this kind of issues. But the problem with exceptional ripple effect, earthquake happens, war happens, this flooding happens, sometimes the political tension between two countries happens, right? Lockdown due to, let's say, labor unrest. There is a problem with laborers in a certain organization and they close down the plant. Or this kind of event, which is a very rare event, pandemic happened, right? Low frequency, high impact disruptions, right? So these are the different type of this ripple effect, right? Now the challenge is because this you don't know what will happen and when it will happen, right? So we cannot forecast that, right? If earthquake will happen this point time and I'll take action, but what I can forecast that in case sometime this event happens, how it is going to impact me. If certain event happens, it might disrupt my supply chain, then what is my backup, right? So look into ripple effect, risk, disruptions. So this is operational, right? So basically demand fluctuation, either you are ordering too low or ordering too high. Structures, critical parameters, right? So this is going to, it is going to impact you structurally, right? So that might be a plant closure. There might be a problem with your transportation. That might be a problem with your suppliers. This is basically, it is going to impact your operational parameters. Might be you will have a backlog. If you have ordered too less, manufacturing has less than whatever has been demanded, there will be backlog of orders. If you have already more inventory, you will have an additional inventory cost. So that is the impact of your bullwhip effect. So this has a recovery time middle. So right now, if you see right now, again, COVID has cases has been surging. But even if you take the best case scenario, it will take few years for all the companies to recover from the supply chain shock. right? Here, Bullwhip effect, again in today's world, the impact has been minimal. Within few days, few weeks, you just like, let's say you have a excess inventory this month. So you reduce your production for the next month so that the excess inventory gets consumed, right? So it is a short-term recovery, right? There are ways to handle that. But unless you have a proper plan for risk management for ripple effect, it will be kind of impossible to get out from this kind of source. Decreased performance, output performance as a annual sales profit, it has going to be a huge impact, right? Here, Bullwhip effect, it is for that fortnight or for that 15 days or month, or might be maybe for a quarter, right? Overall, in a year, you'll be able to manage that. In one quarter, let's say your inventory cost is high because you produce a lot of inventory, you produce a lot of product, but selling, the forecast was not proper, right? Selling was less. So next quarter you'll be producing less, right? So overall in a year you'll be able to manage that. So this is where the short term impact will happen due to Bullwhip effect. So the idea is when we are looking into this ripple effect, so review and refine supply chain. So run different simulation to identify points of risk, right? So this is basically first find out that what are the parameters which we'll discuss, then different type of simulations. So how you run that simulation? Uh, think about in this way, like same example which will take Apple is there and they have like different plants like India, China, Mexico, Philippines, Thailand, right? So they'll identify particular scenarios, right? One scenario is there is a tension between India and China. Second scenario is China is, let's say, like trying certain global tension with Taiwan or Japan, where you are procuring certain raw material, right? So if that case happens, what is the impact on your supply chain? So it might happen that you're not able to transport or you have to close certain plant, manufacturing plant for 6 months or 3 months. So that is the impact. Or let's say you cannot transport certain material from one country to another. So that is the impact or that is the disruption. If that happens, right, if that problem happens, what backup I have? So then you will say that, okay, so the impact is maybe 20 percentage, 10 percentage or 25 percentage loss in sales. So to avoid that, what kind of backup you have? Once you have a backup means that is a contingency plan, right? So some of you who are in the project management, that is what we do, right? But here what happens, you are building that simulation. What is the impact, right? So there it is basically kind of a discussion based on discussion in supply chain. If this happens, because there are a lot of permutation combination. If you start discussing that, it will never going to end, right? Here in software, you can do it in very few seconds, not obviously few seconds. It will take few minutes or few hours, but you'll be able to complete all the scenario, right? Model and simulate points of risk in more detail. Now we say that, okay, if this scenario happens, these are the impact points. So plant number A and plant number B will run into 25% capacity or 50% capacity. My transportation route from point A to B will be impacted. So rather than point A to B, now I have to transport from point A to D, from D to B, right? Something like that. Let's say from China, if you cannot transport to India, then you have to find an alternate route. Maybe from C to A, like transportation from country C to I is not possible, then you transport it from the other countries to India, right? But that backup plan has to be there. Then you put that risk report contingency plans, accordingly review and update your supply chain models, right? So this is where your modeling helps us to kind of build your resilient supply chain. So what are the things you have to look into? One is structural dynamics, operational dynamics, and performance impact dynamics. Structural dynamics is long term, right? So as the name suggests, what is the impact on your structure, supply chain structure? When you say structure, it is not kind of what we mean by regular structure. It is about the supply chain structure. So what do you mean by supply chain structure? So there are four stakeholders: suppliers, your plants, manufacturers, then your warehouses or distribution centers, then your transportation system, the networks, right? From point A to B, you will have transportation system. So these are the four stakeholders, right? How to plan for that? How to plan for supply chain, supply disruptions? How to plan for in case your structure, that your plant itself is locked down or shut down? COVID happened for 2 months, laborers are not there, so your plant will get shut down. So what is the backup for that? Transportation will shut down. You cannot transport from city A to city B. So what is the backup for that, right? Similarly, your distribution center might get shut down. So your plant is running, let's say Mumbai or let's say Pune, but your some states in like northern India are closed now, right? Due to certain unrest. So how to plan for that? Operational dynamics is within that structure, right? Structural dynamics means overall structure, whether what is the backup plan. Now within that structure, whether to store additional inventory, whether to like have a backup plan. Let's say if complete shift, one shift is not done with less worker, so that is where you have to think of long term. How much plant automation is required, so that in case a scenario arises with less number of workers, on only with 25% of workers, you can still run the plant. Shipment dynamics, here you are looking into the transportation, right? How to like put intermodal transportation. So if let's say you cannot transport through road, is there any other method? Then look into the what is the impact, right? What will be the impact on your sales? So sales, you are looking into the profit, obviously revenue, profit. Service level dynamics, which is essential for certain items. Service level means, are you able to meet the customer requirement? If you're not able to meet the customer requirement, next time customer will go to your competitor. Then cost dynamics. Cost dynamics you have to look into to avoid this kind of disruptions. What kind of, obviously long term or the fixed cost you have to do, capital cost. Short term, what is the like disruption? Let's say contingency plan you have to do, right? So these are the three important parameters which you have to look into. So structural dynamics, you have to look into two parts: disruption randomness and recovery randomness. So simply it means, not getting into the details of language, disruption and randomness means what I was just discussing few minutes back. We do not know when these disruptions will happen, right? It is random in nature, right? Apart from this pandemic, even if I take the regular events like war, earthquake, flooding, labor unrest, oil price increase, transportation problem like Suez Canal problem happened few years back. So now, if I look into those things, those disruptions are also random, right? But I know that some way or other, some disruptions will happen. So how to model the randomness of those disruptions, right? So one possible option is to work with homogeneous or heterogeneous probabilities of disruption with different supply chain elements, right? Obviously, you can put, like we used to do in this project management risk register, discuss and put certain probability, homogeneous probability, right? Put probability of zero point 0.4, zero point 0.3, 0.5, zero point 0.6 based on your previous experience, right? Or heterogeneous probability, right? Looking into your, let's say you run certain simulations, right? Run certain kind of scenario analysis from the previous point and look into whether those probabilities differ across time period, right? If you see the like probability of certain events happening has weakened in the last 10 or 15 years, right? Certain disruptions also have reduced. If you look into the Somalia pirates, so they used to like kind of do a lot of disruptions in the sea mode transportation, right? That has reduced. But this kind of disruption when this canal blockage happens, or let's say some problem from the shippers or transporters, that is increasing, right? So this is where we'll put the heterogeneous probability. Heterogeneous probability means not equal, heterogeneous means different. So, or you can just put a scheduled disruption, because I do not know it, like I cannot plan that when the disruption will happen. So you put that either random disruptions or scheduled disruptions event. Put that, okay, I'll assume that okay, this rainy season or this summer season, these problems will happen, right? Which again problematic, right? Our assumptions might be incorrect, right? Same thing, what is happening, our disruptions, right? Also, we have to look into and the recovery also. When I say that okay, this labor unrest will happen or this political tension might happen, election time is coming, obviously there will be certain political tension, so this challenge might occur and our plant may shut down for 10 days or 15 days, right? So that is the disruptions, whatever is happening for you, uh, like shut down a plant, or let's say you have to put certain additional money for your laborers, or get some laborers from outside that state. So those are the disruptions which is happening. Then getting back to the normal, So that is also random, right? You don't know, like COVID happened. Initially, everybody thought within 3 months, 6 months, everything will get to be back into normal, right? And then people started talking about that is the new normal. Right now, we are not so sure about when is that correct time that when COVID won't be there, right? So that is where the randomness in recovery. What is the timeline you'll put that okay, our supply chain will go back to the normal level, pre-COVID or whatever that event happened, right? Again, same thing. You can do a schedule wise, right? You could assume that okay, 15 days, 30 days, 45 days, 3 months, 6 months. So different timeline you'll build and say that if I am able to recover within 15 days, what is the cost to me? If I'm able to recover within 2 months, what is the cost to me? If I'm able to recover within 6 months, what is the cost to me? Right? Then accordingly you define your policies, right? Long-term policies and short-term policies. Then which is a short term, so the structural is a long term scenario, right? You are looking into the what will be my long term plan. Let's say labor unrest happens, one of the strategies to build certain automation in your plant, right? Look into the long term future, because labor unrest will keep happening every 2 or 3 years. Working unions will demand for additional pay and certain unrest for 10 days, 15 days or 30 days, though that has been reducing over years. That but it happens in manufacturing sector, that happens. So to avoid those kinds of scenarios in future, generally plants are getting more and more automated, right? So the kind of impact of human disruptions will be less. Operational parameter dynamics, short term, right? Disruption happened. Now what? So in my plan, that should be option, right? When I have anticipating certain unrest, I know that this problem might happen within 15 days, 30 days. Of course, not all the things, every earthquake and flooding, nobody can anticipate, but political unrest, labor problems, right? Now, what you do, you start building your inventory. You start putting more production or at least outsource some part of your work to your sister organizations, right? Shipment dynamics, which you are shipping, let's say maybe weekly once, you try to ship out your products weekly 2 or 3 times, right? You know that because these discussions with laborers is not going well, you know that this problem might happen, then what to do, right? So you send out your product to different warehouses, right, across India, so that even then your 10 or 15 days your plant gets shut down, no inventory goes out of your plant, still you are able to serve to your customers, right? So inventory control policies, control means how you manage your inventory, how you control how much inventory to stock, how much inventory to build, right? Back ordering rules, back ordering, like when your demand is high, right? Customer is demanding, but your production is not there. Plant is getting shut down, right? Production batching and scheduling algorithms. And sometimes it is not necessarily it is a always outside the problem. It can be internal problem. Your equipment failure happened, right? You do have a preventive maintenance, right? Predictive maintenance, but due to some issue, some problem, one of your big equipment failed, plant equipment failed. That itself is a disruption, right? Not necessarily it is always outside, like kind of a human factor. Sometimes it can be equipment factor also. Now again, you have to think of that. All these things, production planning, back ordering, inventory control, everything you have to look into. Then the impact, like this is in terms of your sales, right? So you have certain, as a supply chain, you will have certain key performance indicators, right? Revenue, sales, service level, fill rate, and cost are typically considered. So this is where you are looking to what will be the impact for different scenarios, right? If scenario A happens, this is the impact on my sales, profit, service level, cost, right? The first decision whether plant performance would be fully recovered or changes to KPI target accepted, right? So the first thing you have to see that okay, if this problem happens, because to recover also it is costly, right? It is not easy, right? Let's say you are losing 10 crores of or 5 crores of quarterly sales, right? But to implement a solution, it is costing you 50 crores in a long term, right? Now you have to look into in case, so that this is where you have to make a decision, backup plan. Okay, in case this problem happens, because this solution is very costly, if even if this problem happens, I'll absorb the cost, or it can be other way around. You know that if this problem happens, your let's say a simple scenario, like lot of this assembly line in automobile plants use these compressors, right? Many compressors are used. Again, compressors are costly. Each one will be costing around 12 lakhs to 50 lakhs. So you'll have lot many compressors. How many compressors you should have in a backup? Because you know that if a compressor failure happens, the compressed air will not be available, your assembly line will not run, this power tools will not run. So there are two options. Long term, I keep all things electric power tools, no need of compressed air. Second, I'll have a backup of these compressors. Keep those backup compressors ready. In case a sudden problem happen, I'll put my backup compressor by the time it gets repaired. Right now, I have to look into the cost of it. To keep a backup compressor, how much it is costing to me, or to make it in a long term, all the power tools, all the assembly line tools automated or not automated, electric, right? They don't need compressed air, that will be running either in battery or electric power. So then you see that, okay, so that is my cost part, right? If I do this, this is my cost. If I do this, this is my total cost. Then what is my in case I do not do anything, I'll just go through it, right? Then how much impact it is going to happen? Maybe half a day loss. In case the compressor fails, by the time it repairs, it will take a half a day. So half a day loss is happening, right? Then what is the cost of that? So that is where your cost benefit analysis also has to happen. Then by what time? So once you decide that whether to absorb that cost or to mitigate that risk, then if your answer is yes, mitigate risk, by how much time you are going to mitigate that risk? Very quickly, right? So it very quickly means you have to have backup compressors, right? But within 6 months, 1 year, right? So you have certain time. Then you will be thinking into long-term scenario, right? Then the final decision concerns how to aggregate the individual performance impacts to the ripple effect at different nodes and arcs in the network, right? One plant problem happens, your equipment failure in one plant. What is the overall impact on your whole supply chain, right? Which are the warehouses will get impacted? Which are the retailers or distributor will get impacted? So this is where your final planning will happen. Okay, that you have to inform them earlier. So when I say inform, you have to keep them ready, right? This kind of event in case future happens. So when you are making a contract with your supplier, right, or with your customers, the outside distributor dealers, so that has to be put in your contract, right? This kind of disruptions, in case disruptions happens, so this will be minimum service level will be able to maintain, right? So how do you model these things in your any kind of software, right? Again, this same thing like what we did in the simulation. Only thing what we do, we look into different options, closing down one plant, closing down certain warehouses, right? And look into try to build different scenarios. So possible site locations and connections. So site locations for our plants, manufacturing plants, warehouses, distribution centers, right? Because these are the two things which is in our control. Customers locations is not in our control. Supplier locations most of the times is not in our control. Discrete and limited number of time periods. How many quarters, how many months we are looking into this kind of disruptions. Deterministic or stochastic demand in periods. So that what we discussed earlier, right? During that period, whether the demand from customers remain fixed, but that also keeps varying. Production, storage, shipment capacities in period, right? So you will have different options. Production in 3 shifts, 2 shifts, uh, one shift or half a shift. Similarly, storage, how much you can keep, like for a future disruption, how much maximum units you can store in a plant, yeah, how much maximum unit you can store in a warehouse, whether you take an additional warehouse to store those units. Shipment capacity, how much maximum shipment. Normally, on an average, you send out 20 trucks or 30 trucks out of your manufacturing plant. But anticipating any disruption, what is the maximum number of shipment you can happen in a day? Lead time service level, in case disruptions happens, what is the changes in lead time? Normally, you take 2 weeks to deliver products to customers. In case disruptions happens, what are the changes impact on that? Again, service level, are you able to meet the all of the customer demand, right? Variables, what are the changes you do? Location, opening, closing. So like I said, either you can close down a plant or open a plant. Beginning and ending inventory in periods. So that is what we talked about, the production and storage, right? How much inventory you have to keep in your warehouses and your production plants. Then production, shipment, setup. holding cost, delay cost, lost sales, fixed cost, processing cost, ordering and back ordering quantities in those periods. So these are the variables we can play with, right? To understand what are the scenarios, different scenarios. So what we are actually modeling, we are not modeling the disruption. Because that disruption we don't know. What kind of disruption, when it will happen, we don't know. But anticipating some problem will happen, what is the impact on our supply chain, that is what we are modeling, right? So basically, this is what you have to look into minimum required performances for every organization, manufacturing organization. This is what already decided, right? So no matter what happens, I'll keep running the plant unless this kind of event happens. And certain plants has to run like kind of regularly, right? Like let's say the steel manufacturing plant, refineries, certain process plant need to be continuously run, right? Otherwise, again starting it, it will take 45 days, 30 to 45 days to keep it ready, right? Burners and all those things, right? So this is what important, right? Initial impact will be this, like COVID happened. Initial impact everybody thought will be in this range, right? But right now, if you see, a lot of companies, manufacturing companies, have been hit very badly, right? Now, what is the long-term impact, right? So the problem is right now in inside we can model all these things, but modeling these things in like for future is very difficult, right? Because none of us or anybody in this world cannot be sure that okay, when this kind of events will happen again and what will be the impact on that, which is like kind of this pandemic. But what we can do in case this kind of event happens, what are the different type of impact? My maximum impact can be all of my plants might get closed, right? So if all my plants get closed, how much inventory will have and how many months still I can serve to my customers? So that is the worst case scenario, right? Then you go start building from that worst case scenario. Out of my 10 plants, I'll keep only one plant running, other 9 plants closed, and these are the warehouses which I'll keep open, right? So let's say I have again going back to that Apple analogy, I have 10 plants and 10,000 warehouses or 8,000 warehouses, right? So how many permutation combinations? Manually, it will not be possible to run all those. So this is where we do a scenario analysis. Different permutation combinations. This plant open, this warehouse is closed, right? What are the different permutation combinations? Then you have a backup for that, right? Then the idea is over time you are going back to your original service level, original performance level, right? This is what where I said long-term planning for any kind of disruption has to be there, right? Which will be taken care, like some obviously very kind of generic ideas, like let's say where you have human interventions, right? A lot of things happens in automation, uh, but equipment's failure, you will have a backup equipment, right? So these are like generic ideas, and plants or organizations keep implementing that. But the challenge happens in this kind of event, right? War happened suddenly, pandemic happened, right? How to kind of mitigate this kind of risk, because this is not in your control. This happens and it impacts everybody, all the stakeholders, customers, suppliers, and you, right? The manufacturer, right? So I think that's all for your risk modeling in your supply chain. Okay. Any questions? Any doubt? That completes your syllabus. So like I mentioned, for your end term, section A will be short answer type. Section B, look into whatever we have done in the classes, right? Look into how to apply that in a real life, right? If I talk about FMCG company, certain problem happened or they have to decide on the certain network optimization or transport optimization. How will they go about it, right? So think about that. What you have studied so far, how you will apply in a real life scenario. That's all. Any questions? Anybody having any doubt? Okay, if not, I'll close for today. Please be ready for your quiz in next class. Okay, chalo, bye bye.
Thank you, sir.
Yeah.